llama.cpp, what it is, what it does, and who's competing with it. On March 10, 2023, a Bulgarian software engineer named Georgi Gerganov pushed a commit to GitHub that would reshape the AI landscape. His project, llama.cpp, implemented Meta's newly released Llama model in pure C and C++, no Python, no PyTorch, no GPU required. Within days, people were running large language models on MacBooks, Raspberry Pis, and Android phones. The story begins in late 2022, when Gerganov started building GGML, a lightweight C library for tensor algebra. His first big project with it was Whisper.cpp, a C implementation of OpenAI's Whisper speech recognition. It proved the concept. Serious neural networks could run on consumer CPUs. Then Meta released the Llama weights. In roughly a weekend, Gerganov ported the inference code to his C tensor library. The initial results were electric. 16 tokens per second on a MacBook Pro, 1 token per second on a phone, and even a Raspberry Pi could run the 7 billion parameter model. Slowly, but it worked. The project exploded. The key insight is that LLM inference is memory bandwidth bound, not compute bound. During text generation, the bottleneck is loading model weights from RAM, not multiplying them. So if you make the model smaller through quantization, reducing 16-bit floats to 4-bit integers, you can run it much faster on the same hardware. Llama.cpp introduced K-quant variants that use mixed precision, keeping important layers at higher precision while aggressively quantizing less sensitive ones. A 7 billion parameter model that takes 14 gigabytes at full precision shrinks to just 4 gigabytes at Q4KM quantization with very minor quality loss. The GGUF file format, introduced in August 2023, became the standard. It stores both model weights and metadata in a single binary file, designed for fast memory-mapped loading. Today, Hugging Face hosts thousands of GGUF models, and when a new open-source model drops, community members race to publish GGUF conversions within hours. On February 20th, 2026 came the biggest news yet. GGML.ai, Gerganov's company, officially joined Hugging Face. The acquisition makes strategic sense. Hugging Face already hosts the models. Now they control the most popular way to run them locally. Gerganov and team maintain full autonomy, the projects stay open source, and Hugging Face provides long-term institutional backing. The llama.cpp ecosystem is vast. Ollama wraps it in a Docker-like experience. Pull a model, run it, done. LM Studio gives you a beautiful desktop GUI. Jan offers a privacy-focused assistant. Llama CPP Python provides Python bindings. Llama file bundles the model and runtime into a single executable. All of these speak the GGUF format, meaning one downloaded model works everywhere. But competition is heating up. Llama v2 is 20 to 50% faster on NVIDIA GPUs with hand-tuned CUDA kernels. Apple MLX delivers 21 to 87% higher throughput on Apple Silicon thanks to native unified memory operations. MLC LLM offers the best mobile cross-compilation. Microsoft's ONX runtime powers Windows Copilot. So why does llama.cpp still dominate? Universality. It runs on CPUs, NVIDIA GPUs, AMD GPUs, Apple Metal, Vulkan, Intel Cycle, ARM, and even mainframes. No other framework matches this breadth. Add the largest model ecosystem via GGUF, and you have infrastructure that's hard to displace. Who should care? Anyone building local AI, application developers avoiding API lock-in, privacy-focused teams in healthcare and finance, edge AI engineers targeting mobile and IoT, agent builders running thousands of inference calls per day without API bills. The bottom line, llama.cpp is one of the most consequential open-source projects of the AI era. A weekend project became foundational infrastructure. Now backed by Hugging Face, with 85,000 GitHub stars and growing, it's not just a tool, it's the engine of local AI. Understanding it isn't optional anymore. For the full article with benchmark tables, code examples, and all references, visit thinksmart.life/research.